All right, guys. So we're going to be reviewing the special right triangles. This is not something we covered before. So special right triangles. And you guessed it, these are going to be right triangles. So these are rules essentially for certain degrees. And it's going to help you find missing sides, especially when you have more than one missing side. So we'll start off with our 45, 90. Okay. So it's going to look something like this. Is this a scale? No. So we have one leg. We know that this is going to be a right angle. We know this is going to be 90 degrees. This is going to be 45 degrees. And this is going to be 45 degrees. Now, if you see a triangle that only lists 145 degrees and a 90 degrees, you can automatically know from the triangle angle sum theorem that the third angle is going to be 45 degrees, okay? Or if you see two angles are 45 degrees, you know the third angle has to be a 90-degree angle. Okay, so our hypotenuse, what would normally be our hypotenuse, would be measured as L times the square root of 2. So if you know what your leg is, you can automatically find the hypotenuse by multiplying it by the square root of 2. Okay, so, what'd I do? Oh, my bad. Okay, so that's our 45, 90. So let's say I had just a quick small example, not a real example, but let's just say I had something like this. This 6, and we're looking for x. We know x is the hypotenuse. Automatically, I could know this other leg is 6 because it's a 45, 90. And then, so I know this x has to be L, which is our 6, times the square root of 2. And that's your final answer. Okay. And our other special type of right triangle is going to be our 30, 60, 90. So let me just write special right triangle. Okay, 30, 60, 90, special right triangle. Okay, so 30, 60, 90. So when we have a 30, 60, 90, we know that it's going to look something like this. So this shortest side, if you drew a line towards there, that would be your 30-degree angle. Okay. And then your second shortest line would be this one down here. That would be your 60-degree angle. And then if you drew out from the right angle, that's going to be your hypotenuse. And this is going to be 90 degrees. So 30, 60, 90. Our shortest side is going to be coming out directly from 30. So like right here. And we could just call that S. And coming out from our second shortest side is going to be right here out of 60 degrees. That's going to be S square root of 3. And if we drew directly out of our hypotenuse, that would just be right here. That would be 2S. So let's say I had a triangle like this. Oh, wait, hold on. So it looks something like this. Oh, geez Louise. Hold on. Sure. Okay. Perfect? No, absolutely not. Okay. 60 degrees. That's 90 degrees. We can automatically assume this is going to be 30 degrees. Same thing as before. You can use a triangle angle sum theorem to know that the last side is going to be 30 degrees. Okay. So let's say the only one we know is going to be, let's say the only one we know is going to be this one out here. And let's say the S is going to be a 4. Okay, so that means our S is equal to 4 because it came directly out from our 30 degrees. So that means coming out from our 60 degrees, it's going to be 4 times the square root of 3. So it'd be 4 square root of 3. And then coming out this way, it's going to be 2 times S, which is 2 times 4, which is 8. Okay. Okay, so let's take a look at something probably a little more complex. Okay. Let's take a look at this beautiful triangle. Whoa, not beautiful. Sure. Okay, that'll do. Okay, so we know this is 45 degrees. We know this is 90-degree angle. Automatically, I know this is a 45, 45, 90 triangle. Okay, so I know one of the sides is going to be 3 square root of 6 over 2. This is going to be V. This is going to be U. Okay, so 45, 45, 90. I know that this is going to be my L. So L is equal to 3 square root of 6 over 2. I already know this V is L, no matter what. I don't have to change anything. So V is equal to 3 square root of 6 divided by 2. Done. Halfway through the problem. Easy peasy. Okay, and then our hypotenuse is equal to L square root of 2. So our hypotenuse is our U. So U is going to equal to 3 square root of 6 over 2 times the square root of 2. Remember, when you're multiplying square roots, you can put them under the same root together, okay? So we can do U is equal to 3 times the square root of 12 over 2. Reminder, pull out pairs from a variable tree. Okay, so if I have 12, I always try to see if I can divide by 2. 2 is the easiest number. It's an even number, so I can divide by 2. We get 6. Same thing, if I can divide by 2, might as well do it. 2, 3. So 2 and 3 are both prime numbers, and this is a pair, so I can bring that out to the front. So it's going to be U is equal to 3 times 2 times. The only number we have left is 3. We have to leave that under the square root. Remember, you can come out as a pair of friends. If you're a loner, you got to stick underneath the square root. Okay, and then divide by 2. Those will cancel out. Or you could just know that 6 divided by 2 gives you 3. Either way, it gives you the same answer. So U is equal to 3 square root of 3. That's your final answer. So we have our two answers here. This is our V, and this is our U. Okay? Okay, let's see. Okay, so let's say we have this next problem. A, B. So let's say we have, this is going to be our 60. And then this is our 3. Okay, so we know that this is our hypotenuse, right? So the hypotenuse was 2s. So 3 is equal to 2s. So this is all for s. All I have to do is divide both sides by 2. The 2's cancel out. So I get 3 over 2 is equal to s, which is great because b is just s. Okay, so now comes the little bit trickier part of the s square root of 3. But just based off this form, there's really not much else we can do, right? Because when you have So a is equal to s square root of 3. Let me double check. Yeah, square root of 3. Okay, so there's nothing really can change. So we're just going to have a is equal to 3 halves square root of 3. If you want it to be all one fraction, you could, it's equivalent. It doesn't matter how you write it. You could write it as 3 square root of 3 over 2. Either answer, oopsies. Either answer is correct. And then your B is this right up here, 3 halves. Okay, so let's take a look at another one. Let's say we have something like that. And this is a 60-degree angle. And we know this is our 9, x, y. So we know our hypotenuse coming out is going to be 2s. So 9 is equal to 2s. Divide both sides by 2. 4.5. Actually, we'll leave it in that terms. 9 over 2 is equal to s. And so this is 90, this is 60. That means this has to be 30. So our y is equal to s, which is equal to 9 over 2. So we can leave it in that form. It's totally fine. And then same thing for the, but now we're going to do it for the x. So x is equal to s times the square root of 3. So 9 over 2 times the square root of 3. Or same thing as before, you can rewrite it as 9 square root of 3 over the same bottom. Either way, gives you the same answer. Okay, and let's look at one final one. So let's say we have this nice little 45. Remember, when you see a 45 and 90-degree angle, you automatically know that third angle is going to be 45 degrees. So let's say this is 5. This is AB. So we know that both sides are going to be equal. So B is equal to 5. That's our L. Okay. And then our hypotenuse is going to be equal to L square root of 2. It's equal to our A. And then so our A is equal to 5 square root of 2. That one's pretty easy. That's all we got to do. There might be problems where you have the A and then you got to solve for the L, but you would just divide by square root of 2 on both sides. Perfect. Then that covers some of these problems.